Hi everyone. Before we start, just in case if you are looking out for preparation for top tech companies and FAANG-based interviews, check out Renaissance, which is a comprehensive interview prep program where you get to learn data structures, algorithms, CS fundamentals, low-level design, and high-level design in a great detail. The problem says we have been given an integer array nums. Okay. Now we have to return true if there exists a triple of indices I, j, k. I, j, and k are indices. So they'll vary from 0 to n minus 1. Now, the index I should be strictly smaller than j. And same thing for j and k. J should be strictly smaller than k. And what we want is that nums of I should also be strictly smaller than nums of j, and nums of j should also be strictly smaller than nums of k. So like if you take this thing as an example, and let's say you are taking this index, and this index, you can clearly see that 1 is smaller than 3 and 3 is smaller than 5. So I can return true. But in this case, can you see any triplet like that? Do you see any triplet I, j, k such that array of I is smaller than j and j is smaller than array of j is smaller than array k? Given that I index comes before j and j comes before. The indices should not be consecutive in nature. You see, where is it saying that? It is saying I, j, k can be anything. The only thing is that I should be smaller index, j should be larger than that, and k should be further larger. That's it. Okay, here they are saying that there is a triplet called as, they have picked index 3, 4, and 5. The index 3 is this, index 4 is that, index 5 is that, and 0 is smaller than 4, 4 is smaller than 6, so they return true. Okay, apart from this triplet, is there any other triplet also in this thing, which you can tell me? Yeah, so Ajay is saying he can see 2, 5, and 6. That is absolutely right. 2 is smaller than 5, 5 is smaller than 6. Some of you are saying 0 to 6. Okay, so by 0 you mean 0 index, by 2 you mean index 2, and I think this will be 5. This index will be 5 then, right? So 0, 2, 5. Tisha, if you're saying that. Okay, cool. So how do I solve this question? What can be the easiest way to approach it? Any ideas around that? 3 loops, isn't it? So I have already written those 3 loops over here for you. So I can write 3 loops. So my I starts from 0, j, because j has to be greater than I. So you can see that j is starting from I plus 1. J is not restarting from 0. J is starting from I plus 1. Why? Because j has to be greater than I. For the same reason, k also starts from j plus 1. Now when you come inside, when you enter the body of the third for loop, then you have I smaller than j, j smaller than k. So here you have just got to compare a of I, a of j, and a of k. So you just got to check if your a of I is smaller than a of j, and further a of j is smaller than a of k, right? If this condition is true for any of the I, j, k triplet, then you can return true, as simple as that. Is it making sense to everyone? The brute force solution to this problem? Do you get that? So what is the time complexity according to you guys? It will be n cube, because you can see there are 3 nested loops and all of them at max can run for n times. So it will be around n cube. Okay, can we do better? So a lot of you are talking about the idea of prefix sum and suffix sum. How many of you believe that that idea can be handy over here? Let's say there is a random array and then there is an element inside it called as x. Okay. Now you're looking out for a triplet. You're looking out for a triplet, and we know that triplet has 3 elements: first, second, third. Okay. When can I say that x is eligible to be second element of my triplet? When can I say that? I can say that if there is at least one element in this part which is smaller than x? Yes or no? If there is at least one element in this part which is smaller than x. Similarly, if there is at least one element in this part which is larger than x, right? Now think of it like that. If you know the minimum element in this part, which is if you know the prefix min in this part, then your job will get done. Because let us imagine this element is 7. And if the prefix min in this part is 9, what would that mean? That means that all the element behind 7 are greater than 7. So you can't get ahead with that. Are you getting my point? How many of you are getting my point? Right? But if the prefix min in this part is smaller than 7, it means that, yeah, there is at least one element. I don't care what that element is, but there is one element for sure, which is smaller than 7. Similarly, in this part, what is it that we can track? Think of it. Maximum, isn't it? What if we know the suffix max in this part? If the suffix max in this part is greater than 7, it guarantees that there is at least one element towards the right side of 7, which is greater than it. So no matter where that element is, what that is, that can be picked and just put up over here instead of question mark. So if you track prefix min and suffix max, then you don't need this loop, because then for each element, you can check what is its prefix min and what is its suffix max, and based on that, you can intelligently take your decision. Is it making sense? How many of you understand it?